Hi everyone, welcome back to a new video. Today's LeetCode daily challenge is minimum 1-bit operations to make an integer 0. This is a hard level question. So let's see the problem description now. We have been given an integer n, and what we have been told that we need to transform it to 0 by performing some operations which can be done any number of times, but we have to try to perform the operation as minimum time as possible. Okay, so we can perform actually two types of operation. One is that we can change the value at the zeroth or the rightmost index. We can flip it. If it is 0, we can change it into 1, and if it is 1, we can change it into 0 according to our requirement. And the other operation that we have been told is that we can change the ith value. Okay, if the value at I minus 1th position is 1 and I minus 2th position through 0 bit means I minus 2, and after that all the values are supposed to be 0. So let's see with an example what it means. If we have an integer, like here we have been given n is equals to 3, right? So it is 1 and 1. Now they have told us that we can change this bit to 0, right? We can change 0th bit as many times as possible to get our required answer. Now first what we have to do, they have told that in the I minus 1th position the value should be 1, and after that all the values can be 0, right? Now after this one we don't have any value, so on the required basis we have 1 on the I minus 1th position, so we can flip this 1. So what we will do, we will flip this and it will become 0 and 1. We have performed one operation now. After this we have only one left, right? So for the 0th index what we can do, we can simply flip it, so it will become 0 and 0. Now in two operations we have changed a value from 3 to 0, right, using only two operations. Let's see one more example. If we have, let's say, 110, right? So what we have to do here, on the 0th index we have 0, first index we have 1, and second index we have 1. So what, for the second operation we were told that we can change the ith bit in the binary representation if I minus 1th bit is set to 1 and I minus 2 through 0th bit are set to 0. Now as we see here, we have I minus 1th bit as 1, and after that we have 0 also. So we can flip the value at second index. So we will flip it as 0. Now we have 0, 1 and 0, right? So we have performed one operation now. After this what we have to do, we need to flip this also. So for flipping this we need to have 1 here, right? And after that we need to have 0. Since no values are after this, so the minimum requirement is that we need to have 1 here. So what we will do, we will flip the value on the 0th index first. So we will perform one more operation and we will flip the value to 1. Now we have the value to satisfy the second operation, right? So we can flip this value. So now we have 0, 0 and 1. Now we have performed total number of 3 operations, right? On the 0th index we can directly flip the value now. So what we will do, we will flip it to 0. So after four operations we have flipped the value from 110, that is equals to 6, to 0. Now let's see the approach to this question. So in this, what we have to do, we will start by checking that if n is greater than 0 or not. So our loop will run in a way that it will check first while n is greater than 0, and if it is greater than 0, then what we have to do? We have to flip the rightmost integers, right? We have a condition or a operation where we can flip the rightmost value. So in order to do that, what we can do? We can use XOR operations, right? So we will perform XOR operation with n and n minus 1. So what this will do is, it will set the rightmost bit to 0 and it will leave the rest of the value as unchanged. So now if we have an answer, right, we have initialized it with 0, then we can store this value in answer. Now we are using here negative value because we are subtracting this from the answer. Okay. So now what we have here, we have flipped the integer or the rightmost binary digit according to our need, and now what we have to do, we need to update the value of n also. So what we will do, n is equals to n and n minus 1. So now we will get the value decreased, and after this loop what we can do, we can simply return the answer. So let's move on to the code. So whatever little doubts will be there, it will be cleared with it. So let's see the code now. Now we will initialize a value which will be storing our answer, and now we will check that if n is greater than 0 or not, and we will iterate on n. Now we have checked that while n is greater than 0, so what we will do, we have to perform the flipping of the integers and we will store it, right, by subtracting from 1 to n, right. So now what we will do, we will do minus answer minus n XOR n minus 1. Now we have to update the value of n also. So what we will do, n is equals to n and n minus 1. Out of this loop, what we can do, we can just return the answer. So let's try to run it. Now we see that we are getting wrong answer. The reason is because when here the answer we are storing is forming in the form of negative value, so we will just return the absolute value of it. So we will return absolute of the answer. We will try to run it again. The sample test cases are passed. Let's try to submit it. So this is that's it for today, guys. Thank you for watching, and if this video helped you out even a little bit, please let me know in the comments, and subscribe to the channel and hit the bell notification so you can be notified every time I post a new video. You can also check out my new playlist where I will be posting 30 days of JavaScript challenge.